This is our MEGN 301 final project presentation by Jude, Aden, Colin, Mayson, and I, Storm.
Plastic production is ever growing and is expected to continue exponentially. One way to reduce the impact left by plastic waste is by recycling and reusing thermoplastics. Our task was to design and manufacture a bulk-size plastic shredder for the first step of the process.
In order to create a good prototype, we first had to set forth some objectives and constraints. The primary goals of the prototype were to take in plastic pieces no larger than 2 inches in any direction and output plastic chips no larger than 1/4 inch in any direction. Furthermore, the prototype had to be portable, user-friendly, safe, and reliable so that it could reasonably be refined and sold as a genuine product later on. As for constraints, the prototype had to be produced within a $230 budget and a 12-week timeline. Due to limitations in component availability, it also had to be powered by a 1/3 horsepower, 1,750 RPM electric motor.
The features of our project include a brake rotor flywheel to increase the potential energy of the system, a durable U-strut frame for stiff support for the housing and motor, a chain to drive the blender with a gear ratio of 3.6:1 to increase the torque and decrease the speed, a cylindrical blender chamber suspended over a collection bin, a perforated aluminum sheet clamped between housing and lower support bearings for size filtering out the plastic once it's the right size, a perforated aluminum sheet clamped between housing and lower support bearings for size filtering out the plastic once it's the right size, a 3D printed hopper for feeding material into the blender while preventing plastic from coming back out, and lastly, a specialized collection bin to collect the plastic once it's the proper size.
The key takeaways we got from this project was that we figured out why industrial shredders aren't oriented vertically. Because of the high speed around a vertical axis, there was a lot of vibrations and wobbling and instability in the system. We also learned how to work together as a team, kind of the dynamics of an engineering project team, and we delegated tasks to everyone's abilities, and I think it worked out really well in the end.
If our team was given the budget to design a second prototype, we would focus on 3 main aspects: safety, efficiency, and streamlined manufacturing. A larger enclosure would create more space between the blender intake and dangerous spinning components, as well as increase the throughput. We would also add protective cover on the chain and stabilize the frame to increase safety. To improve efficiency, fixed blades could be added inside the chamber in order to provide a surface to shear against. The perforated plate would be made of a stronger material to keep it from bending. And finally, a more polished prototype would benefit from the use of higher tolerance tools like water jets, washers and bolts that are more appropriately sized, and a mounted e-stop.